So, have you ever really stopped to wonder what's going on inside the mind of an AI? Well, today, we're going to pull back the curtain on the single most important mechanism that's powering pretty much everything you see. From GPT to BERT, we're diving deep into the secret engine of modern AI, a little something called scaled dot product attention.
I mean, think about it for a second. When you ask something like ChatGPT a question, it's not just seeing a string of words. It gets the nuance, it understands the context, the relationships between words. But how? How does it actually grasp the meaning that's woven into our language?
Well, the answer is right here. It's this powerful and honestly surprisingly elegant concept called the attention mechanism. And look, this isn't just one piece of the puzzle, it is the very foundation of the transformer architecture that has totally revolutionized the entire field. So let's break it down.
Now, to really appreciate why attention is such a massive breakthrough, we have to first understand the problem it was designed to solve. And it was a really big problem, a problem of memory. Just imagine trying to read a long paragraph, but you can only remember the last few words you just read. That was the reality for older AI models. You see, they processed information sequentially, one word at a time, and that meant crucial context from the beginning of a sentence could just disappear by the time it got to the end. This was a huge roadblock, and it limited AI's ability to understand anything more complex than a simple phrase.
So, how did the researchers get around this memory problem? Well, they came up with this brilliant new approach. Instead of reading word by word, they asked, what if the AI could just look at the entire sentence all at once?
And that, right there, is the core idea of attention. It gives the model this ability to weigh the importance of every single word in relation to every other word, and it does it instantly. It's kind of like having a bird's eye view of the whole sentence instead of just walking through it with blinders on.
To really get this, let's use an analogy. Imagine the AI is like a hyper-efficient digital librarian. For any word it's looking at, it creates a query. Think of this as its search term. It then compares that query to a set of keys, which are like the titles in a card catalog for every other word in the sentence. And once it finds the best matches, it pulls the values. That's the actual content, the books themselves. Okay, this whole librarian thing is a great way to think about it, but how does it actually work on a mathematical level? Let's pop the hood and look at the four-step recipe that makes this whole thing tick.
All right, don't panic. I know this formula looks a little intimidating, but I promise you it is way simpler than it appears. It's really just a compact way of writing down our librarian's entire workflow. We're going to break it down piece by piece. So here's the roadmap, the game plan. Our three inputs, the query, the key, and the value, they go in one end. They then move through this four-step pipeline: score, stabilize, normalize, and finally aggregate. And what comes out the other side is a brand new context-rich understanding of that original word. Let's hit step one. First things first, the model has to figure out how relevant every other word is to the word it's currently focused on. And it does this by taking its query and multiplying it by every single key in the sentence. The result? A simple score. The higher the score, the stronger the connection. Simple as that. Step two is a really crucial but simple housekeeping step. You see, sometimes those scores can get really, really big, which can totally mess up the learning process later on. So to keep things from getting out of hand, the model just divides all the scores by a scaling factor. It's a neat little trick that makes sure the model learns smoothly and doesn't, explode. And now, for the magic. In step three, we take those nice, stable, raw scores, and we run them through a function called softmax. All this thing does is convert those numbers into clean percentages that all add up to 100%. These are the attention weights. This tells the model exactly how much focus it should give to each and every word in the sentence. And finally, we're at step four. The model takes those attention percentages and multiplies them by the value of each word. Remember, that's the actual substance. Words with high attention weights, they get amplified. Words with low weights, they get pushed into the background, suppressed. The end result is a brand new representation of the original word, but now it's packed with rich context from the entire sentence. So there you have it. That's the four-step process. A simple, really elegant calculation. But this calculation didn't just improve AI, it completely transformed it. Let's see exactly why. Take a look at this sentence. For you and me, it's totally obvious that it refers to the animal. But for an older AI, this was a surprisingly tough problem. How could it possibly know that it wasn't talking about the road? And this is where the power of attention just shines. When the model processes the word it, its attention mechanism scans the entire sentence, runs those calculations, and finds a super strong connection back to animal. It gives animal a really high attention weight and road a very, very low one. Ambiguity solved instantly.
So the crucial difference is right here. Older models were like a chain, passing information down a line, and the signal would get weaker and weaker the further it went. Attention is more like a fully connected network, where every word has a direct, instantaneous line to every other word. This whole direct access design gives attention 3 superpowers. First, it can capture relationships between words no matter how far apart they are in a sentence. Second, it can do all its calculations at the same time, which makes it incredibly fast on modern GPUs. And third, it learns context on the fly, adapting to the unique meaning of every single sentence it ever sees. So when you really boil it all down, scaled dot product attention is so much more than just a formula. It's the engine that gave AI a true sense of context. It's what allows a model to weigh importance, to understand relationships, and to reason about language in a way that, let's be honest, feels almost human. This one mechanism completely changed the game. It gave AI the kind of long-term memory it desperately needed to finally understand us. And that leaves us with a final, pretty fascinating question to chew on. What's the next fundamental ability that AI is going to need to unlock?